sequence. By the end of this, you will know the formulas for the sequences and be able to use the recursive and explicit formula. So a lot of jargony here, a lot of letters. I know it's math, but a lot of letters here. Just understand that there is subscript, tiny little itty-bitty writing here. That's A, little n, for the number we're trying to find. And to find that number, we always want to go backwards 1. So we're going to subtract 1. So that's why we do A minus 1, and then add the difference. This is to find a number in a series using the number before it. So that's what this means here. Go backwards 1, and then just add how much they have in common, or that much, how much they're apart. The other thing is to find a number. You could use an explicit formula, where if we know what the first term is, again, I'm putting all of these subscript in green, we can add the difference, the number of times minus 1, so 1 less than what we're trying to find. And kind of let me explain that to you. Draw yourself a little stick figure of you on the second step. Okay, here I am on the second step, and I want to try to get to the second number, which if I follow along, third, fourth, fifth, sixth is the sixth step. Now, how many would I have to go up and over in order to get to the second number? How many would that be an increase of? It's an increase of 4, right? So our common difference is 4. If I'm starting, that's the first step, and this is the ground here. If I'm starting at the second step, to get to the next number in our sequence, I'd have to add 4. So it's kind of skip counting here. So I'd have to go up another 4. 1, 2, 3, 4 would be up here. Our next number would be 10. This would be the third number in our sequence. So that's what we're going to see here. Now, because we didn't start on the ground, because we're starting with our first value, that's where this subtraction of 1 comes in. Where instead of starting at 0, I'm starting with our first number, and I need to use that number in order to get to the next. So I'm going to go back 1 after time. I'll do a better job of explaining this as we kind of work with some of these problems. All right. So the explicit rule and the recursive rule, I've got it written down here. Yours is at the top of the page. So feel free to just use this as a reference. You're going to want to have this available to you. Anyways, so let's consider this sequence that we have. 9, 12, 15, 18. If we were trying to put these in like an order, the first number would be 9. The second number would be 12. The third number would be 15. And the fourth number would be 18. So you've got numbers talking about numbers. And that's what makes it a little bit confusing for some people, that we have numbers and other numbers involved. But just understand that it's the first number, the second number, third number, and the fourth number in this sequence. So if we're going to find the first term, the initial term, we can call this a little 1 or a1 with parentheses around it. Either way you go with it, the first number is, in fact, 9. What would you say their common difference is? What would you say they're changing by? There should be a pattern. It is a sequence.
Changing by 3.
Good. So the common difference is 3. And we want to use the recursive rule, okay, to find the fifth term, which is the next number. Now, common sense would be able to help you find this. What's the next number? What's the fifth number? Jonah. 21. Now, how did you do that, Jonah? How did you know it was 21? You added 3 to 18. And that's because the 18 is in the fourth spot. So Jonah went back 1 spot and added 3 to that number. And that's what you're going to tell a computer. So how do we tell a computer to do this math? Well, to find the fifth term, and again, this is the recursive rule, we have to go backwards 1. So we're going to do 5 minus 1. And then whatever that number is, we're going to add 3 to it. We're going to add the difference. So Jonah went back 1 place. He wanted to find find this number. So we went backwards 1, so we subtracted 1 to get to the 4th spot. What is the number in that 4th spot? It is 18. And what do you do to 18 to find the next number? You would add 21. Okay? To find the number, we're going to start with the first. We're going to add the difference. We'll do that one last time. So we're going to find the 5th number. This time, instead of using the 1 before it, I know that I start at 9. And in order to get to the 5th number of starting at 9, I'm going to have to go up 1, 2, 3, 4 times. Okay? So I'm going to go up 3, 1 less than the number I'm trying to find. Because again, you're not starting at the bottom. You're starting on the first step. So to get to the 5th step, I only have to go up 4 times, 1 less. Change my color here. So this would be 4 times. We're going to go up 3, 4 times for that matter. So 3 times 4 is 12, and 9 plus 12 again is 21. So you got the same answer, you just did it a little bit differently. So to find the 10th term, it would be best to use the explicit formula. Because it would find the 10th term without having to find all the terms that came before. Explicit rule up there, so looking at the boxes, let's fill in the table. Yes, sometimes you can see this in table form. So we're asked, how many boxes are there in the first group? First group, how many boxes? Lincoln says 1, Aiden says 1. Yes, there is 1. How many boxes in the second group? Jonah. Come on, this isn't hard, folks. Boxes in the third group. Count them. 5, yep. Then 7, and then 9. So there we have it. What could we say is the common difference for these? Hey, going up by 2. Sometimes they go down, going up by 2. So again, let's look at the recursive and the explicit rule. Always go back to your notes here. They want us to use B for boxes. Okay, so fine. B1, we always have to say what that is in fact 1. There's only 1 box. So to find some number of boxes, something down the road, this doesn't change, this doesn't change. It's simply, I'm going to go backwards 1. So when you go backwards 1, like if I'm trying to find the 6th, the number of boxes in the 6th spot, I'm going to go backwards 1 and then add how many to that? What's the common difference? I'm going to add 2, right? So the next number will be 11. So I'm going to go back 1 spot and add 2 to it. The explicit definition works a little bit differently. Again, I am going to use Bn. I don't have to state the first term because I end up using it. A1 or B1, whatever it is, the first set of boxes is just 1. Its common difference is going up by 2. And to find whatever number we're looking for, we're going to do that 1 less than the number I'm trying to find because I'm already using the first number here. All right? How are we doing? Based on the function, based on the sequence, what's our first term? The very first one, based on what they tell you. 1, right? That's that number right there. So the first number is 1. I'm now going to use that to find the other terms. So I'm going to find the second term. So A2, the number I'm trying to find is 2. So I'm starting at 1. I know it's 2 more than 1 less than the number I'm trying to find, which I should have put in as 2. So 2 minus 1. So order of operations says parentheses first. So if I'm trying to find the second number, I'm going to go up by 2 1 time. All right? 2 times 1 is 2. 2 plus 1 is 3. Makes sense. Starting at 1 and adding 2 every time is 3. Let's find the third number, shall we? I'm going to start with the first number. I'm going to add 2. Now, how many times am I going to add 2 to find the third number? 1 less than the number I'm trying to find. So I'm trying to find the third number. I only have to do it 2 times. So, multiply, then you add, and that's going to be 4 plus 1. How about 5? So far I've done 1, 3, 5. I'm kind of out of room, so I'm just going to come over to the side here. Who can tell me the fourth number and the fifth number? Fourth, fifth. 1, 3, 5. Skip counting. That's all it is. Jonah? Here we go. Okay. This is the place that it's in, and this is the actual number that we have. So the first number is 1. Put it down. Over 1 up 1. The second number is 3. So over 2 up 3. The third number is 5. The fourth number is 7. And the fifth number is in fact 9. So it would go 1, 3, 5, 7, 9. Now, why should we not connect the points in a continuous straight line? Well, the reason is there's no values between the points. There's no 2.5. There's no 2. There's no 4, 1, 4, 2, 5. The sequence skips numbers, and connecting them would include numbers not in the sequence. So sequences don't get connected. Is just representing the number we're trying to find. So A 21. We're going to try to find the 21st number. Now you could clearly go 1, 3, 5, 7, 9, 12, 11, 13, all the way out, but I actually could probably beat you, because if I start at 1, I'm going to add 2 times 20 times. Alright? I'm going to add 2 20 times, 1 less than number I'm trying to find. So 1 plus 2 times 20, and 1 plus 2, we're going to multiply first. How about 41 is the 21st number. So, let's see if we can make some sense out of this. Consider the sequence given by the following definition. B1, what's that telling us? Whether it was A1, B1, C1, Q1, I don't care. What's it telling us? What's the 1 saying?
Is the original for the first one?
7 is the first number, right? 7 is the first number, and then all of this jargon, this is the key. What's that plus 4 mean? Starts at 7 and don't make it harder than it is today. It's June. I'm not trying to make your rocket sciences here. Jonah? Goes up by 4. So that's all that means. First number is 7, and the numbers in the sequence increase by 4. Okay? So you want to find the first 4 terms officially, and that would be done by using the formula. So B1, we know is 7. B2 would be B2 minus 1 plus 4. Go backwards 1 place and use the first number, add 4 to it. The number in the first spot is 7. So that means the second number is 11. But a lot of you are not taking the Regents this year, so today we can just draw a couple of quick lines and know that if we start at 7 and increase by 4, the next number would be 11. The next number after that would be 15. And the next number after that would be 19. Okay? So there you have it. After you get that down, please go ahead and try the You Try question, which is exercise number 5. All right, let's finish it up here. We have to find the 4th number, to be technical, B1, B2, B3, B4. Angie, what's the first number we've got based on the information told to us? go, starting at -3 and adding 6.